This is a video on surface integrals and mass. The question states, find the mass of the surface S with density ρ, where the surface S is defined by the function z is equal to 9 minus x squared minus y squared for x between 0 and 1 and y between 0 and 2. And the density is defined by ρ at the point x comma y comma z is equal to x plus 2z. So let's recall that the mass of a surface S with density ρ is given by the surface integral over S of ρ of xyz ds. And surface integrals are defined when we have a function z equals a function of xy by a double integral over the region R of the density function evaluated at x comma y, and instead of z, we plug in g of xy, where g of xy is z equals g of xy defined as a surface. And then times the square root of 1 plus g sub x squared plus g sub y squared dA. So let's find g sub x and g sub y. G of xy is 9 minus x squared minus y squared. So g sub x is the partial derivative of this function with respect to x, which is just negative 2x. And g sub y is the partial derivative with respect to y of 9 minus x squared minus y squared. And that's just negative 2y. So now I can put everything together, and I get the mass is equal to the double integral. We have x is between 0 and 1, so x goes from 0 to 1. Y is between 0 and 2, so y goes from 0 to 2. And then the density function is x plus 2z, so I have x plus 2, and then z is 9 minus x squared minus y squared, so we have times 9 minus x squared minus y squared. And then times the square root of 1 plus g sub x squared, negative 2x quantity squared is 4x squared. And then plus g sub y squared, negative 2y quantity squared is 4y squared. Then dy dx. So I could do this integral by hand. It would be a lot of work, and it would involve trig substitution and other substitution techniques. But instead, I actually used a calculator, and I got that this double integral is about equal to 75.12. So I can conclude that the mass of our surface S with this density function is about equal to 75.12. And I'm done with the problem.